So I started the lecture for the 2.211, the linearity or linear homogeneity, and or the profit function and supply function and the input demand functions, they also are homogeneous. Firstly, pi was profit. Okay, we discussed about the previous lecture. This is the pi, the profit to the target function for the optimization. So, and the pi has the property of the linearity with price with respect to the price speed. This is the first point. It describes mathematically any of the lambda pi with lambda multiplied profit price and input prices, then the S goes out for the outside. This is equivalent. This is a linearity. We discussed the scaling. If you put a request you put the input twice or third, you can get the twice third product from the firm. Second point, zero sub-homogeneous and the hoteling lemma implies this function. In these cases, for the amount of the product, amount of the input is scaling in the linear. Put many and get many, but inside in the sense of the price, even if you put such the lambda inside the price, but y doesn't change for such the optimized the data, and it's same things happening in the x. Usually, you can understand x and y. There's some specific relation. Then you can get max according to the maximization of the price, depending on demand. Even you change the price doesn't change here, because increasing the price and increasing the increasing of the input price and the output price simultaneously. Okay, is keeping balance the same way. That's why the maximized point doesn't change. This is coming from their balancing CGE analysis. It implies producer behavior or behavior with the company or firm only depend on the relative prices. This is the market. Always is balancing. That's why change of the price is again the balancing, then keeping same thing, the behavior. That's why producer behavior doesn't change absolute price, but relative prices. 2.2, according to the Euler theorem, and we use zero sub-homogeneous. Function f bit complicated originally in like this, but then pi is defined this way. It's a kind of the optimization problem to find some peak point in the multidimensional surfaces. But you can decompose summation of each dimensional peak. Okay. This is the coming of the Euler theorem and the zero sub-homogeneous point. In this sense, okay, calculation getting easier because you can separately calculate the peak point individual component So then get result. This is the point of this calculation. Indeed, in this formulation, normally it's balancing. This factor goes zero because of the equation 4. This way, okay? It goes zero, in fact. This is a balancing issue. It means zero profit, no profit, okay? Interesting. You may feel curiosity, why profit zero? No. Company try to get profit. That's why they are working. But according to the definition, CGE analysis, coming from mathematics. Okay, anyway, the drop profit means for the firms have technology. Okay, this is the point of linearity. Firms have a technology to keep a constant return with respect to scale. Okay, put input many. You can get many products. It's very natural. Then for ideal price taker, maximize profit equals sell. Keep balance. Then cancel. Then this factor and this factor, it goes to the equivalent. Therefore, in this formulation, no profit. In the CGE analysis, you may try to analyze here your computer simulation. So many companies go to the no profit, in fact. This is not curious for the CGE analysis. Okay, then you can think more deeply the meaning for the mathematical definition. Why zero profit? This is coming from mathematical formulation CGE, especially for the profit definition of F. Indeed, profit in this sense, okay, is goals balances. Therefore, actual sense of the profit in the real world, like actual accounting process, yes, company try to keep their own profit and accumulate it, and then save. They can keep saves. It's in the part of the function and in the or the input. Therefore, profit in the real world is, we can understand, payment to use of capital. Payment to use capital. What is this? Okay. Again, we are discussing what is the capital. Capital means land, spaces, facilities, buildings, machine, human worker cost, having in the firm or company. This is also input. In this sense, yes, input is not for the payment for the buying things, but also paying is necessary cost or past, present, future in this company. That's why ideal price taker have to be the balance, keep balances. Zero profit, it means the balancing, keeping this management, the money. Okay, then summary and the point, and capital is how the household. We discussed the three components: market, firms, and household. Household is the worker, actual worker, the buyer. So then capital is the household. Then firms borrow and use capital from the household. Then firms have to pay a rental fee of the capital from the household. This is the structure of this economical model. Okay. So second point, the 2.2, cost minimization behavior. We learned profit maximization is a kind of the function of the price taker at the firm. Company try to take maximize profit, indeed it's about zero profit, but this is the mirroring or the coupling together in the aspect of the cost minimization. Therefore, firms take profit maximization behavior, simultaneously take cost minimization behavior. So then we can go to the definition of the cost function for unit one piece of the product, the input. How much cost is necessary for making one product? This is a formulation, CP is the kind of minimization. This is also optimization problem because of the V defined by the one product. Under the condition, then we need to minimize for the cost. Then get CP. How we can calculate the cost minimization in one unit, we use Lagrangian. Lagrangian formulation is very convenient and also very popular on the nonlinear optimization problem. If function can be defined as a continuous and differentiable, we usually use the Lagrangian multiplier method. For this method, foundation of the cost minimization can be derived this way, then can compute an actual cost for this. The best input to minimize the cost is C, according to the calculation. Then Z1, Z2, Zn is decided by P, and then C, minimize the cost, can be derived for one product. The previous classes, the one question arises, okay, what is the difference of the linear programming and the nonlinear programming? Lagrangian multiplier method is one of the typical methods to solve the nonlinear problem, optimization problem. Wikipedia providing a very nice visualized explanation of the Lagrangian multiplier method, even if they are multi-variable cases. Now I'm shortly introduce for the way with the mathematical method in the mathematical optimization in order to find the maximum or minimum of fx, subject to equality constraint dx. You can consider the x is a vector, but now I simply define such as the vector or single variable. Lagrangian function defined L, x original variable plus Lagrangian multiplier lambda. Why this is called the multiplier means if lambda is multiplied the gx. Lambda in a sense is the unknown parameter. We try to minimize the lambda in the partial differentials. This method usually use not only the optimization problem. For example, we analyze the assist device system or simulate the dynamics robot or the assistive mechanism. We usually use such a the Lagrange multiplier inside the program. In fact, we also have some specific method to solve for this. Okay, mathematically, if you formulate this, okay, maximize f, with this example, if you assume x and y and subject g and xy, then we can visualize this. Okay, this is a very intuitively understanding. Okay, what is f? What is f is a kind of the surface, I said, even the much valuable things, mountain. there's some the mountain, then there's some peak and surface. If this is non-constraint optimization, you just take one peak on the surface. That's all, everything. But normally, we have some constraint. No, you cannot climb the top of the mountain. There's some condition. That's why condition always satisfied in this problem. So in these cases, you also need to think about the constraint attached to the surface. Not this, not this, not this. Oh, this is the constraint. That's why you need to find such a the best point to satisfy the condition. This is for the picture. If there's some the equivalent point f x y equals d1, this is a kind of a counter map. Counter map that represents time height in the mountain. Okay, you may see that the three-dimensional map at counter map. So then this is the line to satisfy f x y equal d1, d2, d3. Okay, you need to find the attaching point gxy equals 0. Not exact attaching point, it is a gradient of this point, and gradient of the f is equivalent. That's why this curve this way, and then this way, gradient is equivalent. That's why this is a point of interest. We need to try to find this point. This is equivalent to this, and then satisfy this. Okay. Therefore, partial differentials is necessary to calculate this. For example, okay, you can get such a hint more exact example. Okay, we formulate the simple example. 2x plus 3y is a target f function. Subject to x squared, the y squared, the summation of these components equals 1. In this formulation given, you just change the component to this side, and then set equal 0 function. Then, how you can solve the Lagrangian? You can set first component. First component set here. Second component set here. Multiplied lambda. Then you need to solve partial differential. Okay, in this cases, okay, you are partial differential by x, okay, 2x lambda. Okay, y, okay, 3, 2y lambda. Lambda, this component. That's all. Then you can calculate the other multiple regression, then get the solution by the removing for the lambda here. Then get this value, then this is the optimized point. Is it true or not? You can visualize again. So this is a line. As I said, this is the equivalent point. This is the line 2x 3y equals 6. 2x 3y equals 12. Okay, 2x plus 3y something is this kind of line. Then condition here, 2 squared, the x squared, the y squared plus the two component equals 0 is the kind of circle. So then it represents the line finally attaching some point. Then get solution here. This is the equivalent for the solution of the Lagrangian multiplier. That's beautiful, the mathematics. Okay. So the next issue. Okay, there's some subsection the following the corporate behavior, but now we are skipping for the consumer behavior. 3.2, spending minimization of behavior to minimize spending. This is the same thing in occur. We discussed for the corporate behavior. Corporate behavior is the profit maximization. It's equivalent to the cost minimization because of the formulation. From say profit maximization behavior simultaneously take cost minimization behavior. Same thing we can say in the consumer behavior. No, sorry. The third point, the consumer behavior, firstly. We focus a representative consumer to describe it mathematically. And consumer behavior as a utility or satisfaction is defined as utility function U, G. Okay, utility function G is defined at the provided the utility level and with input the demand or consumption. Then this is the input vector D. Then demand vector is it is called the demand vector. You may doubt, okay, no, utility level not only for the consumption, buying things, but also leisure, vacation, something else. But we formulate very simply, focusing on the consumption. Then what we can say leisure or some other things, also buying action. So then we can say again, G is a quasi-continuous function because of the to use Lagrangian to get the point to satisfy the condition. So then 3.1, utility maximizing behavior. There is some budget constraint. Oh, I have money this. Only for this, what kind of things I can maximize my utility. Therefore, constraint coming from the M is the budget constraint. It's balanced. How many things that you want to buy and prices. Then input vector, P1, P2, things you want to buy and the budget. Then you try to maximize utility level. Then again, we introduce Lagrangian according to the assumption, quasi-continuous function or continuous or differentiable. Then G is defined with multiplier lambda. Then you can calculate blah, blah, blah. Once you formulate it this way, very, very nicely, you put these things then solver can take the optimized answer very nicely. That's the power of the mathematics and the formulate the Lagrangian. Only you need note such a kind of the assumption of the function or some other thing, how you define G and F appropriate way, not only to represent the real world, but also mathematical the condition. If so, you can get the best demand to maximize utility, then you can find indirect utility function, get some target factor or the value of interest for this. Function of demand to maximize utility, usually people use the technical term Marshallian demand function. If you read an article related to this field, then they say Marshallian demand function, blah, blah, blah. Ah, I see. They are calculating this way. You can understand the backside mathematical basement from the keyword. Then indirect utility function is optimized. P and M is used, then get V. Again, we are saying this is balanced, and then those are the homogeneous. So then 3.2, spending minimization. As I say, yes, consumer behavior, the same tendency for the firm or the corporate behavior, cost minimization, profit maximization, the connect the cost minimization simultaneously. Therefore, you can understand the same mirroring the situation. Utilization maximization and the same as as well as the spending minimization. Then you can consider spending minimization behavior, formulate this. In this case, you try to maximize utility here. Then this cases, minimize spending, focusing on the given utility level U. In these cases, the corporate behavior, we formulated only one unit production. Instead of that, we focusing on the U, given utility level, kind of constant. Then minimize the summation of the PY/HY is the price versus amount of the things to buy, goods. So then you again define Lagrangian. Then calculate this and get solution by solver. H is the solution. Then spending function E is defined after the optimization. Same as before, in the case of the maximizing utility, the Marshallian demand function of demand to minimize spending is the Hicksian demand function, Hickson's function. Compensate the demand function. Then this is a balanced. Okay. Okay, I think according to time limitation, I think this is the final topic today. I would like to go to the chapter second, general equilibrium model. Okay, so just I'm shortly introduce the point. There are some several approaches, traditional approach and dual approach. Then I'm simply explained from the traditional approach here. So we discuss about the market, a three-component market, and the enterprises, corporate, and then the consumer in the household. Then firstly, enterprise, the corporate behavior can be defined and the same as before, output Y and the function F. What is the difference is YI, because of the product is not only one. That's why multiple function exist to providing different products. That's why the abbreviation or the increase the number of the point for only one I, but you can change the I depending on the product. So then newly introduced the intermediate goods or output, input amount of goods. Now more the formulation is more bit complicated later, but now it tentatively please understand for the input, intermediate goods on the way, and goods. Okay. So then the practically separated X and V, intermediate goods and the input amount of goods. That's why the vector X, V are different now. Then pi is a profit. It's also the parameter as added as I, depending on the product I. So then other formulation is equivalent. Then you can get such a partial differential for Lagrangian and the to solve this the balancing effect. Whole household the budget and the consumer behavior, utilization the level is given by the G, and GD is the same, and the maximization of the utilization utility maximizing they occur, and then we can say about the M income. We say budget for consumption we said is actually the represent the income of the household. How much money households have, then they can buy the product, in fact. Firstly, finally, we can focusing in the market equilibrium. Such as the corporate behavior, the customer behavior connect in the market. That's why market equilibrium is maintained. That's why supply and demand is keep the balance, and then we assume this is equivalent. Therefore, market equilibrium in production, how such a factor price determined is defined this formulation. Supply and demand is balanced. Then intermediate goods. Then summary. 2.4 is a list of the formulation. You can put these things into your computer simulation. Firstly, production function, profit maximization function, equilibrium condition in goods market, equilibrium condition of factor market, and definition of income. And this equation with variable. These are connecting, okay? Very complicated way, but simply define here. Y is used, okay, the X is used here, V is used here, and then the X is coming here again, here, and M is again for the another part of the optimization. These are connecting, then solves one output, then after the keeping balances. This is a system for the equilibrium conditional phenomenon, and then general equilibrium model. Okay. Is there any question? Okay. the equilibrium.
My question is about the equilibrium.
Yes.
Is from that formula, the supply is equal to demand.
Yes.
Yeah.
Yes.
Here, the equilibrium, the word equilibrium came from this formula that there is balance between supplies and demand.
Yes, supply and demand in the market equilibrium for the consumer side and the company side, all together. Because they put something and then they yes, firstly describing. Yes. So then we discussed at the beginning, and this is the market, and price is determining the demand and supply keeping. But this is actually supported by the household budget. This is kind of the dynamics inside, maximize the utility within a given budget. And then this is the profit maximization occur from the enterprise process. Then supply of the goods, production factor demand, and then the financial needs and then factor supply. We need to represent these action. What is the keeping balance again? This is the function disk. Okay.
Okay.
This is the point. This is the D1. D is coming from the here.
Household.
It related the household. And then this is coming for the company side here. Inside the household, some the balancing occur. In the enterprise side, it's balancing occur. This is the point.
Mike, another question about if the variables are used in different formulas.
Yes.
The GTAB model, how it solve it? Does it solve it stimulously?
Yes, this is an interesting point. This is the point. Yes, if it's connecting simultaneously, it's not so easy to solve. But if it's the function is totally non-linear, for example, x1, x2, blah blah blah. And not easy to solve, but if you can solve alpha, the k and x, and beta, the k, the 2 Prof. Linearly decomposed. It's possible. It doesn't mind how you can solve which one the first. This is a very interesting point of view. That formulation is very important. That's why some mathematical treatment, okay, we can separate this. In that cases, even you solve this, or this, opposite direction, no problem at all. Finally, you can get optimized solution.
They use the logarithmic or log to reform in a linear form.
The only thing is that we need to think for the linearity. Its function f for the x and the x and okay. y is fx and fy, or the f alpha x alpha fx. Any of the function, even the logarithmic, the linear or non-linear, if it satisfies this relation, the solution getting easy to solve, okay? Because we can decompose one by one depending on the factor. This is a kind of system in the mathematics side. Okay? Yes.
Thank you very much, Professor.
Okay,
Thank
that's
you very
right,
much.
fine.
Thank you very
Okay,
much.
thank you very much.